Share the screen. So webhook is a API call. Webhooks are used to send some changes to the CI server to perform a kind of operations against your things. And more on actually here, first let me looking at EBS volumes. EBS volumes. So what is the volume here? This is the one. 8 GB. Let us try to modify the volume from suppose 20 GB to modify it. Modify. Let's go to instance. Let us refresh. We're looking at the storage. So no issues at all. If it is not working, we will try to try at the latter side because I don't want to waste your time. So on the fly, you try to sit at the GitHub and configure your pipeline. So just send API call. This is API call. Sorry. What this API call is, this is the kind of payload actually, right? The payload will send some changes, send changes to the target server, target server, target server. The server is here just for sake of understanding. We took the Jenkins, right? So the why the current so first you try to looking at the storage. Volume ID only one. Only 8 GB. Let us try to add the one more volume. But it is added, right? But in use, let us try to attach to this volume, attach the volume, right click. It's already attached, right? Okay. So meanwhile, we'll try to look for the changes. Last day, we are going to assign a webhook. How to attach the webhooks? Go to the settings and here webhooks. So let me delete the existing one. Verify. This is additional work. Play Store. So let me give the ID. So here, try to click on Add Webhooks. Generally, here you should give the Jenkins URL. This is our Jenkins URL. It is HTTP. Let's go and add the HTTP slash GitHub hyphen webhook. Okay. So generally, it should work. But last day when I add this, suppose if I take like application JSON, just go and add webhook. It is sometimes unexpected data pockets, ups and downs. It should actually, it should. Just half an hour back, we got some debate on this. We don't want to add external keys actually. We don't want to add the keys because Jenkins is a URL that allows the request from the GitHub. GitHub is sending webhooks. There is nothing wrong. But anyhow, we got the success. Okay. Now see, you should get this one tick mark in the sense deliver was successful. Now to run this job, now there is one more problem is Jenkins is a server. Server requires some space. That's a major problem. Just go and click on build node. It's going to be execute. So you're looking at free space 0, very less space. Do one thing. Let us go to the dashboard. Now click on new item. Now I have to practically show. What is practically we need to show when something was pushed at the repository. So whenever Mr. X developer push the changes, whenever they give the changes to this repository, suppose right now I'm in this project. So if I do some changes here, automatically webhook send some changes to the Jenkins in order to trigger it automatically. You don't need to run it. For example, I'm just run my first pipeline, click on freestyle, click on OK. See, this is in the Jenkins window. First, you have to select the Git. Okay. So you have to enter the repository URL. Why should I enter the repository URL? Because Jenkins is going to identify the changes at the repository, right? So Repository is, this is my repository. Copy this, HTTPS, go to this one, just, okay. Now, how Jenkins receive the notification, how the Jenkins automatically detects the change if something was happened at the repository like a master branch. So that's why once you set the Jenkins URL in the GitHub side, the same time you have to choose an option called this one. Please select this option. GitHub hook trigger for Git SCM polling. You have to run this. You have to select this option. Again, I'm repeating, my intention is how to demonstrate webhooks. For that, I took the Jenkins as a server. So anyhow, the already example is succeed. And what is that? We already successfully create the payload URL. In the payload URL, don't confuse, guys. You should give this payload URL with the, what is the target URL? IP address with the port number and GitHub-webhook. So HTTP colon IP address Jenkins IP colon port number 8080 slash GitHub hyphen webhook, right? This is the one we have to copy and paste inside the your GitHub URL, right? So in the GitHub place. So that's it. If you get the tick mark, the changes are get ready. But here, due to some less space in the Jenkins side, for example, see, what I'm doing is right now, just I'm adding a small job, just apply. I'm not doing anything, just click on save. Okay. What is our job name? First pipeline. See, whenever you add this, we get the GitHub log actually. Don't looking at the Jenkins as of now. Later we'll discuss Jenkins architecture, Jenkins nodes, master slave concept, pipelines, types of pipelines, administration. A lot of stuff is there, we'll discuss. So now to demonstrate this one, I do one thing, go to the repository. Suppose something I'm trying to modify it. For example, I just open this Docker file. I just go and click on something. I'm just giving my email ID is suppose sri@cloud@gmail.com. Okay, just I'm at the master branch. Now looking at here, if you go to the dashboard, right now it's not built. Okay, you just go to this. Now I'm going to do some changes, right? This is a Docker file. At the master branch, I'm going to commit the changes. Commit changes. Go and see it. See? It is in queue, right? See, read that, started by GitHub push by Sri Srinivas, waiting for the next available executor. That is Jenkins node issue. Already we trigger it. So if I go and see it, see, waiting for the next, in the sense I said, right, this is a Jenkins node issue actually, because we don't have sufficient space. Got my point? If you go and click on GitHub, see, started by event, looking at on the Thursday, something like. So Jenkins automatically detects the changes, right? ఇక్కడ ఎందుకు రన్ అవ్వట్లేదండి, why it doesn't in the sense node issues, right? Node issue in the sense what? If you go to the dashboard, manage Jenkins, under manage Jenkins, see, there is a nodes. See, right now, built-in node, Linux, see, swap space is very, very less. Suppose if you want to add the new node, again, it's the biggest topic, and the configuration windows we'll discuss in the Jenkins part. If I say built-in node, So bring this node back online. Wait, but it won't take, again, it's going to be back. So disk space is a below threshold. Then if you go to our repository, they're not repository, if you go to the volumes, then I do one thing. Let me detach the volume. After detach the volume, you might still be charged for volume storage. If you no longer need the volume, delete it to stop incurring the changes. So I అసలు ఇదేనా దీనిదేనా 2025 619, yeah, this one all. So do one thing. See, the concept is over. We wait for the execution only. Jenkins automatically detects the change, right? Right. Even if you try again. So if you go again, do some changes. Just commit changes, then commit changes, go there. We all updated, right? Okay, I think so. Do something. Let's try. Commit changes, commit changes. What's the time now? Hmm. So unless until you are not, we should change the disk. Again, I have to stop this EC2 instance. Go back to the instance. My Gita. Okay. Right click. Stop the instance. So let us try. So when I increase the disk space, whether the Jenkins is going to enable. So the concept is done. Whenever changes are encountered, Jenkins like GitHub is automatically send the notification. That's all. But let me try one more time. Then if not, let us see. Basically running very slow due to network. That is one more major issue. Last day also it ran due to the network slow only. Maybe request was sent to the server, but taking too much time to travel to send the packets to the server. So maybe server is get delayed to receive the request from the client side. That's the reason we got the error, but actually it works. Hmm? You should, very blind example is tick mark. I should not say as a professional, tick in the sense deliver successful. In the sense, GitHub is going to talk to the Jenkins external systems. Suppose if I go to my volumes, detach this volume. Okay. Now, but see, something is missing, guys. Select here. Volume is 75720, 20 GB. If I go to this volume, right click, attach the volume. to the my get. Device name is dvxvda attach volume. So successfully attached. Okay, now it is in use. Go to this instance. Now we stop the EC2 instance, right? Now when I restart, go and start instance. Let us see the IP address of this EC2 instance. Go to the details. Now 65. This is one thing you have to understand. When you stop and restart, EC2 is automatically regenerates the IP address. This is the worst thing. Every time my application domain is changing the server IP, the end user will make the complaints. So you need a stable IP. We'll discuss in the cloud that is called elastic IP. Elastic IP. Elastic IP is a chargeable thing. For example, gmail.com is always change or static. Right, that is. So you have to buy the static IP from the Amazon. That IP should be fixed. Obviously, if you go to the settings, maybe Jenkins IP should be changed, right? Suppose if I run this, it won't, right? Same previous is a 15 dot. Now we need to copy this 65 dot, go to this one, copy 8080. Sorry. The slow. So what is username? Admin. Password is also admin. So got it. Got the point? It's already over. Jenkins, like GitHub, successfully deliver the message. That's it. So ఇక్కడ ఏంటంటే we need to cross check the again we have to go with the disk management. It will take too much time. Just we'll fix it in the EVS volumes. I'll tell you. Anyhow, Jenkins we need to start right. There I can fix it. So Jenkins always runs on the server side. Jenkins requires some extra space to run our jobs actually. Job is nothing but again a simple pipeline. Okay, right now bring this node back online. So moreover, internet issues going on. I pray. See, go to this dashboard. So again, it won't change it. ఇది మాట్లాడాలి అంటే how to change this, sir? We have to go to the disk. We have to increase the. Already we added the 20 GB disk, right? We already added the 20 GB disk, right? If you go to the EC2 instance, that's why Linux skills is mandatory. ఇక్కడ అర్థమవుతుంది మీకు. So disk space is not there. Then disk space is a concept of Linux or and then disk. సో డిస్క్ మేనేజ్మెంట్ వద్దంటే ఎట్లా? ఇప్పుడు మీకు బెస్ట్ ఎగ్జాంపుల్ క్లియర్ చూపిస్తుంది కదా, సేయింగ్ లైక్ ఐఎమ్ నాట్ హ్యావింగ్ సఫిషియంట్ స్పేస్, రైట్? ఈవెన్ ఇఫ్ యూ గో టు ద నోట్స్, go to the dashboards. Hey, look at that. First pipeline is success, right? So నీది కొంచెం డిఫరెంట్ ఉన్నట్టుంది నీలాగే అది కూడా. ఎస్. ఎందుకు వస్తుంది అదే నీలాగే కొంచెం ఏదో దానికి బాగా. ఎస్, ఇన్స్టెన్స్ ఈజ్ రెడీ. సో దాట్స్ ఇట్, లైక్ వెరీ సింపుల్ డెలివరీ ఆఫ్ నెట్వర్క్స్, జస్ట్ లివ్ ఇట్. సో if the job is successfully run it, right, success, right, it means it will downloads the code. Our ETU project is successfully going to inside the Jenkins workspace, if I right, if I'm not wrong. So just leave it. When you push something, it automatically runs the pipeline. That's it. For example, if you go to the webhooks, so 15 is different, right? Delete this one. See, this started by the get push events. And we got, if you go to the console output, just like slow, delivery of networks bit slow. So we didn't run it, guys. Keep this point. We never click on the build now. So GitHub in the hooks in the sense what we don't run it. There are two types of runs: manual run and automation run. Automatically, Jenkins will trigger it. So meanwhile, you copy this. Copy. Now, you're testing, you see? Got it. అర్థమవుతుందండి. This is automatically clone the repository. So do one thing, go to this EC2 instance, connect, connect. So whenever you do the changes at the repository, Jenkins automatically send the notification. So cd where lib Jenkins. In the Jenkins, we have workspace actually. cd workspace. Under workspace, see our first pipeline we created, right? cd first pipeline. If we go there, job name actually. See, this code is there or not? Our code, right? అంతే కదండి. సో అంటే ఏంటి, వాట్ వి డిడ్ యాక్చువల్లీ, when I push some changes to the branch, master branch, that code will automatically hand out to the Jenkins and run the job. That is called webhook. Automatic detection of the change at the specific branch. Whenever you do some changes at the branch, webhook send that notification to the Jenkins. So Jenkins will automatically run some job based on your detection, right? That is. So if you go, suppose ls rm minus rf off. Right now it's empty. Let us go to the pipeline. Let me go to the webhooks. Before that, what is our new IP? Copy, go to the webhooks, add webhooks. Now GitHub hyphen webhook, right? Slash. So I'm going to select the application JSON. Now add webhook. We got success. Now if you go some changes at the repository, suppose ETE, I'm going to add some file here, upload file. So choose the file. Suppose go back. Suppose there is a class 17 file. Just open. Okay. Now commit changes. Then go to the Jenkins. Right now it is at 1. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . If I say right now, ls, right now nothing is available. ls, wait. Now again, back. Some space is dancing actually. So even if you see 30 seconds ago, right? Started by the GitHub push by Srinivas, waiting for 42 seconds. So it means it is trying to check the Babu, your node is not able to allow me. Please up it because less disk space available. So that's why just leave it, move for the next tool called as a continuous integration. Today we'll start the heading. It's a very important, powerful concept. In the continuous integration, whatever 3 to 4 topics we missed in the GitHub will come back. So see the ls. Okay. So far, before starts this automation, so we successfully completes the GitHub Actions, GitLab integration, Git commands, some kind of stuff we discussed, and 3 to 4 projects we did. Let us go for the next process called build tools. Most powerful thing in the continuous integration. So once we complete the CI process, we'll start the cloud platform. Once we complete the cloud platform, we go for continuous delivery. That is an order. If I say ls, maybe it will take some time, just leave it. Okay. Clear is it? So what is a webhook? Automatically Jenkins receive the notification from the repository. We configure this GitHub manually. We go to the webhook, select settings, webhook, give the Jenkins payload URL. But in automation, sometimes they'll ask this question, I don't want to configure manually. Is it possible to develop the automation scripts? For that, we'll discuss later in the Jenkins. Okay. Now, the most prestigious concept, continuous integration. Okay. I think so. Amrit and Narayana will enjoy it. And this is their area. So let us see how they will. Huh? So one thing. Next, put the heading right. Continuous integration. Continuous integration. So in the continuous integration, we successfully complete the source code management. So here we need to introduce a concept called build automation. Introduce the concept of build automation. Build automation. This is. So in the build automation, we will focus on the Maven, then dependency analysis, then testing, like unit testing, then code coverage, then static analysis, security testing, then we'll discuss about the generating packages, Okay, next we will focus on deploying deploying packages to local repositories. Deploying packages to local repositories. That is, we are going to handling binary artifacts, binary artifactory tools like here JFrog and Nexus. JFrog and Nexus. So in this dependency analysis, we focus on OSAP dependency. OSAP. OSAP top 10. What do you call? OWOASP. OSAP top 10. Static. This comes under static analysis also. Okay. So for testing, we use a JUnit frameworks. For code coverage, we have a lot of plugins. Later we'll discuss. If you want, I will explain like CMD, PMD, Cobertura, check style, Jaco. So Cobertura. What tool you are using, Mr. Amrit? Except SonarQube. Are you there? So Cobertura, check style, Jaco, and even CPD, PMD, even find bugs. They're plugins. You don't need to confuse about just plugins, just integrate, run it. You don't be panic about that. Hmm? So for deploying the artifacts, here JFrog. Okay. This is so at the same time, we are going to be focused on another build automation tool in Java-based application is Gradle. What is that? Gradle. 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 Gradle is a tool. Okay. Clear. So there are almost 8 to 9 components comes. We'll discuss. Now see. First of all, we'll discuss what is a build. First, we'll discuss what is a build. What is a build? So generally, when developers are build the source code, each and every developer develop the source code. If you recollect our concept, listen carefully. Suppose, just assume it, there are 5 members in your team. The total company, like you are working in a small company, you are only 5 developers, right? Just assume. Or you can have 100 developers. That does not matter here. Okay. So you build the code and like multiple developers are building the code here, right? Okay. So all the team members are trying to push the source code to the GitHub, right? Before pushing the code to the GitHub, as you know very well, this code should integrate with this code, right? So for integrating this code, this guy raised the pull request. or this guy raised the pull request at the repository. Like this guy also raised the pull request, pull request. So multiple team members raise their pull request. Why? Because integration should work right, like their code should be work right. Once this PR is approval is done, these two codes will be merged right, isn't it? And these two codes also will be merged right. So finally, the ultimately technical lead will take the entire code. He will finally merge, final merge. The final merge is pushed to the particular repo, isn't it? This is. So pull request, approve the pull request, merging should be done successfully. Then only they will commit the source code to the repository. Don't forget that one. So they'll ask this question, definitely how to explain to the interviewers also. So according to your company, how your source code management is deal it in your project. Multiple developers are develop the source code, they do their own commits at the repositories. Once all the codes are tested and perform at unit testing level, they will raise the pull request. Once the PR is accepted, we complete the merge related issues. And once the merging is done, the final lead at the development side, he will take care about all the merging related issues. Once merging is done successfully, they will commit the code to the particular branch of my repository. So whenever developer push the source code to the branch, now next time, like next minute onwards, we have to start build automation, right? Right. So that's before talking about build automation, what is a build? Build is nothing but a set of executable files generated after source code compilation. Build is a set of executable file. Build is a set of executable files generated after source code compilation. Build is set of executable files generated after source code compilation. Again, one more tricky point here is remember it. What is my definition? Source code compilation. Now again you have to, Mr. Amrit or Adinarayana, where are you, man? Just come to my audibility. Come to audible. So suppose he's a developer, like according to he built the code, right? He should compile the code or not in his local machine. Generally, as a basic, as a my work, I will develop my work. Every day I should open my editor, I should compile it, right? So compilation is a common process to remove the problems, right? Like everyone is compile only, they do only test it, then they will push the code to the repository, then merge will be, PR will be raised and they will merge it, right? So each and every individual code will be properly merged at the repository, right? Again, why DevOps engineers should compile the code? So think from the bottom level onwards. Then only you can enjoy the continuous integration. Otherwise, no, people will come to the floors and they'll say, Maven is not required. Lag good essay. If you ask, just call me, right? Hmm? I will lab them, right? Hmm? So what is that? Why should I compile again if my individual developers are already built it? Now, question is, build is nothing but, for example, if I take my entire body, each and every part of the body organ is a small component. So each and every small component, they develop it. As a DevOps engineer, earlier we called as a build and release engineer. Just 10 years back, this role we call as a build and release engineer. Still, a lot of companies are recruiting the build and release engineer, right? Build, release. Simply build the code as a build and release to the teams, right? The question is, why should I compile the code again as a DevOps engineer? Here, DevOps engineers are taking the each and every piece of code, right? He's taking the piece of code and he should connect it, right? Linking. What is that? Linking, right? That's why during the linking, if any library was missed, any code file was missed, any configuration or any some sort of important source code file is missed, The build cannot be formed. That's why always remember it, compilation is done at two stages. At the individual source code compilation, then at the build level compilation is there. So at the build level, who do this? DevOps engineer, right? So once each and every developer build the code, once they will compile, once they test their code at local machine, once after successful merge is done, once they push the code here, again, a DevOps engineer should clone the code from the repository and into his local machine or into Jenkins environment. He should again compile. Why? Because compilation build is nothing but a lots of steps will be there. Compilation is only one process. Linking is only one process, right? So if I'm not compile it, just assume it, you take like car, you break down all the parts of the car, then start fixing each and every one. So once you fix it, you have to retest it, right? Whether it is properly integrated or not. That's why compilation is must. What we are doing? Build level compilation. Then they will ask this question: what is the differences between a compilation and a build? Compilation is a part of build. Compilation is a part of build, right? If immediately they ask this question, why you should do multiple times? Because build is nothing but lots of steps are there. We need to perform multiple activities. One of the activity called the linking. What is that? Linking. So if any one of the link is missed, like important file, configurations, dependencies is missed, you cannot run it. That's why definition point of view, build is nothing but a set of executable files generated when after source code compilation at the build level, right? Clear? Okay. So what are the types of builds? Put this about next types of builds. Types of builds. So types of builds in the sense what? Is again one more confusion to the beginner. Types of builds, nothing but here. I have a 10 to 12 types of builds in my mind. But for your basic experience, maybe I don't know how they have experience in the real world. First, we have a nightly build. What is that? Nightly build. We'll discuss slowly. Nightly, night hours. Next, continuous builds. As of now, today, you just these two words enough. Anyhow, we are going to cover 10 tools in the continuous integration. And another 2 weeks only, we are talking about this, all the tools in the CI. So that we'll discuss almost 5 to 6 types of builds comes, we'll discuss. Sir, what is a nightly build? Nightly build and then nights. After 6:30? True. True, man. It's a true. Looking at really nightly in the sense at nights. Now, looking at, see, looking at. For example, before looking at the nightly build and continuous build, you have to understand a small story, right? For example, before agile process, before agile model. Okay. Nowadays, everyone is working on the agile model quickly. For every 2 weeks, every 10 days, every month, we have a sprint and we are going to release the project to the client. That is a different. That's why DevOps came. We don't want to go back again. So before agile, there is a waterfall model is there. What is that? Waterfall model is a one kind of SDLC model. In SDLC model is an incremental model actually, one after one. Waterfall, waterfalls going to down from the top to like. So first requirement analysis, designing, coding, testing, deployment, release, something like that. The problem in waterfall model is, once requirements are clear, once requirements are precise, once requirements are medium, then only they will take the project. Otherwise, they won't, first of all. And waterfall is completely work for the long periods, like 2 years, 1 year, 4 years also. The big project is there, right? Advantage is a baseline. Disadvantage is also baseline. What is meant by baseline? Baseline in the sense, each and every phase of SDLC will be clearly washed. Like take the inputs. First, they will take the inputs, process it, get the output, and verify it, and they will exit. Entry, input, process, output, exit. Each and every phase will be exit. And here there is no parallel development. Parallel testing is not possible. Once analysis is over, then design. Once design is over, coding. Once the coding is over, testing. Like so, in that model, suppose coding when start. Suppose assume it there is a 1 year project. Just assume it, right? According to software project plan, 1 month for analysis. Okay, 1 month for design, 5 months for coding, uh, 2 months for testing, and remaining for operational team. They want to form the deployment and hand out the production. When they will start testing? After 7 months, right? Free. Simply the testers will free, right? They'll simply understand the functional requirement specification. They will develop their own stories. Music will be the test plan preparation, test design, test case preparation, test reviews, test data preparation, some kind of metrics. అబ్బో అసలు మామూలు అసలు స్టోరీస్ మాన్యువల్ టెస్టర్ సార్. If I ask them quality, 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 right? Sir, okay, it's cool. You are quality people. We understood that. So testing, if I want to start the testing, coding should be over. Once the coding is done, when after 7 months, build and release engineer, build and release engineer, Mr. Developer throw the entire 5 months of code at a time to the build and engineer phases, right? Then as a build and engineer, I have to take it. I have to start manually compile it, test it, generate the package. During that, if any problems are encountered, hand out to the development team. Again, they'll start. So again, and in the sense, when the problem is encountered, again, they should debug it. They should find out the problems where it is done it, right? During that, simply testers are sleeping, right? Because build is not yet ready, right? So this process will delay. Maybe one time, maybe 2 days, 3 days, 5 days, 6 days, 1 week, 10 days also will take. So once the entire code is over, then only build will be start. This is a very irritating process to the industry, right? Now they understood one process is, Are Babu, don't build the, don't generate the build after entire source code compilation is done, entire source code development is over. Do one thing regularly. Whenever my developer develop the code, at the night, suppose after second month, development is started. Third month started, right? Third month, the first day, developer starts the code, right? End of the evening, they will push the code to the repository, they will went off. That movement, nightly build. Once the entire development part is over, Mr. Billion Lead Engineer wake up at the evening 6 o'clock or 7 o'clock. He looking at the repositories like SVN server or something like GitHub. They will take the code, they will start compilation. During the build, if the compilation is failure, so again they should stop it because developers already left the house. So they will send the email to them. But once the office was over, no one will looking at the email. Next day morning, developers should come, they should see the emails, they should fix it. Again, when they fix it, in the evening again, build and release engineer will wait for it. This is a very, very headache process. No, 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 it is not like this. It's not a good practice. That's why the waterfall is somewhat old. Now, Agile is entered into the picture. Agile, every commit, continuously, whenever developer push the code, that is called our webhook. Best example. I don't want to wait for the midnight or evening, morning, I don't know. Whenever you do some changes at the repository, automatically code will take it, compile it. That's what we have to understand. Continuous. Word is all continuous, right? Got my point? That's why in the beginning of the demos, I said continuous integration defined in two ways: pull based mechanism, push based mechanism. A professional should understand this one: pull based and push based, right? So, pull in the sense, looking at pull in the sense, if whenever bill is going to be automate the bill at schedule time, at scheduled time, like nightly bills. Suppose sometimes even in the agile process also we do some types of nightly bills for backup purpose, right? We use it. Continuous integration is a software engineering best practices where whenever there is a changes at the repository, we are going to pull the code, we have to compile the code, we have to test it. That is called push based. Pull in the sense time. Execute the build at scheduled time. Push in the sense execute, execute the, or you can say automate the build, automated the build, automated the build when there are changes are happen. When there are changes happen at repository. We already discussed, right? Happen at repo. So I don't know whether morning or evening, midnight or this time or next 5 minutes, I don't know. Clear my point? So remember this definition. Continuous integration is a best engineering practice where each and where whatever the developers made the changes to the repository can be performed, can be generated the build in two ways. One is a pull-based mechanism and a push-based mechanism. In pull-based mechanism, we are creating the automated build at schedule time. In the push-based, we are generating the build when there is a changes happen at the repository. That's it. Okay. So what is a build? Types of build. Multiple builds are there. We'll discuss incremental build also there. Matrix builds also there. There's a 12 to 13 builds are there. Wait, we'll discuss. As of now, nightly build, continuous build. In agile process, in the current trend, which one use? Continuous build. Continuous in the sense, if there are changes at the repository around the globe, I don't know how many number of developer teams working on the different regions. I don't mind it. The entire repositories are connected to the Jenkins or GitLab, your favorite CI system. If something was happen at the repository, your system automatically detect the change done through webhook. Push-based mechanism is nothing but webhook. Clear? Right. So build types of builds. Next step. Here, what is a build format? So from the beginning, you are telling build is a set of executable files generated after source code compilation. You're saying, right? What is the build format? Build format is jar, var, year, image, jar, Java RQs, web RQs, enterprise RQs, image. Again, you should ask the question, what you are doing? So once the source code is pushed to the repository at the branch, DevOps engineer should take that code. Which code? Code is nothing but what kind of language your developer is used. That's most important. Tip of the day is you are pushing the code. Who will push the code? Developers only. What developer is doing? They develop the code for application. What kind of application they are developing? Web applications. Is it maybe e-commerce or banking or finance or security or mobile application? Using which language? Multiple programming language. So you have to pick your neck logically at the time. If it is a programming language, is a Java. Build format is this one, any one of this. My programming language is a .NET, Microsoft DLL, Dynamic Link Libraries. If you are using Java, the build format should be either Java RQs, Web RQs, Enterprise RQs, and image. Of course, nowadays, image is a quite common to .NET also, Python also, even Go also, maybe your favorite any programming language if you build application. Image is a quite common standard nowadays. But DLL is a Microsoft dynamic link library, right? So what you need to understand here, based on the language, your build tools are different. అర్థమవుతుందా? Can you understand my point? Online and offline. So build types of build formats. So build formats are changing based on the technology and what type of tool you are using. That's why you have to understand build tools. Build tools, right? So build tools. Suppose if it is a Java, so and old tool, another neat tool, and Maven and Gradle. Okay. If you are using .NET, MS Build. If you are using Python, PyBuilder, PyBuilder, right? If you are using Node.js, NPM, Node Package Managers, right? Java, .NET, Python, Node.js, NPM. Even if you use a JavaScript, that is a different Jest. They use a Jest frameworks, right? Okay. Some kind of frameworks are there, right? Okay. So build format, build tools, build types. Okay. Got it. Actually, build format, I said, right? It's wrong. It should be build a file and build file. That is a perfect effective term. Build files. Okay. Someone asked this question. If you want to perform CI, basic file is a build file, right? Okay. That is your responsibility to generate the build files. Build file generate challenge, we'll see, right? We need a build, a source file, we require it. Based on the tools we'll discuss, right? Okay. Now, if it is a build format, if it is a build format, so generally testers, so Mr. Harshavardhan and Adinarayana. So suppose as a tester, you develop the test cases, you develop the test data, you will wait for the build. Whenever DevOps engineers deploy the build into your QA server, we start the sanity test or smoke test and we start. Testing is dead easy, actually. It's a Timbri fellow system. Any people can do the manual testing. That is simple. Manual testing is dead easy, man. Who said it's a complex? Okay. So whenever tester find the developer will fix it. Whenever developer fix it, DevOps engineer, a build engineer, you have to take the change, I have to hand over the change to them as a build number. What is that? Build numbers. So build numbers, versions, patches, hot fixes, fix packs is most important. Okay. So in the build formats, major version dot, minor version dot, a hot fix dot, build number in generally. Build number. Major version dot, minor version dot, patch dot, build number. Major version dot, minor version dot, fix pack dot, build number. Generally, these build numbers are generated by us, DevOps engineers. You have to carefully generate the build numbers and hand out to the DevOps QA teams. Okay, by seeing the build numbers only, in which build you got the defects, if I ask you, so they will see the build history. In this build, we identify the defects, right? So, versions, major versions and minor versions are decided by the client, business team. Okay, got my point? Okay. Here, there are things you have to understand. You know, build is nothing but set of executable files generated after source code compilation. Version is nothing but enhancements of the build. What is that? Enhancement of the build. Enhancements of the build. Enhancements of the build, actually. Patch in the sense a smaller modification given by the developer based on the rejected build. So minor modification given by the developer on the rejected build. That's why I'm a DevOps engineer. I speak from the development stage to the monitoring phase. Everything is in my only right. We know the development, how to develop the Java code, how to understand the patterns, how they will perform the unit testing, Mockito, integration testing. And we know how to generate the builds. We know how to deploy the builds to the QA team, how the QA teams are dancing, like what is the levels of testing, types of testing, performance testing, and functional testing, and the security testing, user acceptance testing. Because we are all developing the long build pipeline. The pipeline is starting to ending, right? That's why we are all integral. We are all integrating all the stages of SDLC into the one synchronized pipeline. We are managing the issues, right? That's why senior teams, senior DevOps teams like me or someone, they must understand the planning stage to the after migration also, right? By seeing that, we have triage meetings. We have triage meetings and war rooms, and we'll discuss what developer is saying and what tester is saying, what network engineering is saying, right? What is security team is saying, like that. If you don't understand their voice, problems will encounter. Especially build is the heart of the continuous integration. So versions important. You should know how to handle the builds. Not handle, you should know how to generate the build. You should know how to integrate the versions, right? How to generate the versions, how to release the versions, right? How to track the versions from build to the QA, dev to the QA, QA to the dev. So tester reject the defect. Suppose tester throw the defect. Developer reject the build. Developer tester again throw the defects. Developer fix it. Fix in the sense he accepted. If she accepted, she should change the code. If she change the source code, there is a change in the build. Again, you have to update the changes or not in the application. They don't. They are tumris actually. Testers are very tumris actually. They are always focusing on the application. Give the input, check the output. Give the input, check the output. Give the input, check the output. They are saying like we are all president. Actually, they are presidents. Just for fun. They are presidents. Their sign is very, very important. If they don't sign it, sorry, we are not sign off the project. In the sense, we are not ready for the release. Okay, boss. What's the problem? Then they'll give open the quality indicators, right? This one, that one, blah, 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 right? So that's a great industry, great teams. అసలు testing meda. So based on the testing level, crores of business, crores, thousands crores of business is running in the entire universe, right? Such a great streaming called IT. ఈ ఐటీ తప్ప ఎవడైనా సరే టెస్టింగ్ మీద జాబ్ ఇప్పించేవాళ్ళు చెప్పమనండి. ఐఎమ్ రియల్లీ గివింగ్ బెస్ట్ పార్టీ టు దెమ్, రైట్? Such a great IT industry that gives like without knowing the programming, that is a quality of the testers, really. Suppose if I want to test the fan, do I really require how to manufacture the fan? No, very common sense. If I want to test the AC, I don't want to, I should not be become expertise in the electrical and electronic engineering side. If I know the functionality, more than enough. Based on that only, you guys are dancing very well, right? I'm a functional tester. I'm a functional tester, automation tester, something like that. Very crazy. So there, DevOps engineers are integral part between the dev and QS. We keep on generates the build, keep on generates the build, keep on. One fine day, build is stable. We are going to hand over to the production environment. That's why continuous integration is the backbone. Lot of steps are there. మన వాళ్ళంతా ప్రాసెస్ పక్కన పెట్టేస్తాం. వీ డోంట్ వాంట్ టు నో ద ప్రాసెస్. వీ వాంట్ డాకర్, కుబర్నెటిస్, టెరాఫార్మ్, క్లౌడ్, ELK, Splunk, Kafka, Grafana, Prometheus, Istio, Service Mesh, and RabbitMQ, ActiveMQ, and Spring Boot. Spring Boot, even Selenium tester should be strong on the Spring Boot. My Java developer is also using Spring Boot. As a DevOps engineer, I'm handling the Spring Boot applications in the production environment. So apart from this, the build and version and a patch. Patch in the sense, small minor rectification given by the developer on the rejected build. You should know how to create the patch. Because of that reason only, 5 top commands I stopped it. Like patching commands we'll discuss. Merging commands we'll discuss. Merging strategies we'll discuss. Stashing. Stash is one of the most powerful topic in the entire Jenkins history, right? And I simply git stash, I will explain it, but there is no use. Even rebase, right? Even git blame, git git reflog. That's why you guys are only looking at the external application code. That's you can't enjoy those commands. But when the context come, definitely you'll enjoy that. In the Jenkins again, we'll recall the 20 top commands in the git again. There we'll discuss actually. Okay. So build, version, patch. Okay. So how it generates the build? How to generates the build then? How to generate the build? How to generate the build? In 2 ways we can generate the build. One is manually and through automation. Through automation. Okay. So manual in the sense, manual process is more time consuming process, boring process, right? So that's why Mr. Testing add-on. So generally when we go for Selenium automation, when there is a changes happen at repository, if there are more regression cycles are long and take, more test repeatability is required. Okay. That movement, instead of doing it manually, we pick up some sample of test cases. We are going to convert into script. Babu, testing is a long old story. Developers are also writing the test cases. They are writing the test cases at the coding level. You are writing the test case at the functional level. That's why they are working as a white box tester. You are working as a black box tester. I am working as a gray box tester. Gray box testing in the sense combination of white plus black box. That's what DevOps engineer. I should know the development. I should know the testing. I should know the operational team also. Right? Why I'm telling this story here? Why? Because one fine day, Tejaswin asking, hey, Srinivas, please start the build. Then I said manual process. Manual in the sense what? Soon after developer pushing the code to the repository, I manually clone the code into my local machine. I manually compile it. I manually test it. While compiling, if some problems encounter it, compilation issues available, dependency failures, okay, lot of linking failures, artifacts not getting incompatible versions, some kind of errors will be come into the picture and unsupported JVM versions, something. I got so many compilation issues at the build level. Tomorrow I will show you technically. So those technical issues, again, I have to alert the email to my developers. Again, developer is again fixing it. Again, they'll push the source code repository. Again, I'm doing manually. Again, I'm compiling. When I do the testing, again, testing is failure. Again, sending back to them. Again, get the feedback. Again, pushing. It's a more time consuming process. Why should I do it manually? Manual is a time consuming process, no consistency, more time taking process, no reusable, no reproducibility, and no consistency towards identification of the bugs. Okay. It will take a lot of interval times and no guarantee. Okay. That's why I should convert this manual process to automation. That's why automation అంటే మీట్ ఒక్కడే కాదు. This is not only testing, it is everything from the development to the monitoring. Automation is instead of doing it manually, you try to convert into script. That is called automation testing. Automation testing again, Selenium, Cypress, Playwright. No, no, no. You should talk about the GitHub Actions, GitLab, Maven, Jenkins, Docker, Kubernetes, Selenium, JUnit, TestNG, all the tools, JMeter, Rest Assured, Postman, everything will come into the picture, right? Clear my point? Hmm? Okay. So through automation, we are going to do it. How to do the automation? Then how to perform build automation? How to perform build automation? How to perform build automation? Using build tools. Using build tools, right? Using build tools, right? Okay, build tools, right? So now we are going to talk about build tool as two most popular tools like Maven and Gradle. We'll do multiple projects here, right? We do multiple projects. Multiple projects in the sense like, can you say 100? No, just like we'll touch every, at least Python, Java, okay, Node.js. If possible, if it is, if I get the code. It's not that much. For every build process, it will take 2 to 3 hours. So 2 to 3 hours in the sun, 2 days, 2 days, right? When should I explain the tools? When should I explain the concept? When should I explain the package? Most of the training, just MEN package over. Take the repository. They will say like in the Maven, there is a build file called the pom.xml file. That is not your job. You never develop the build file. That is only developer's job. So don't looking at the pom.xml file. Just MEN package over. Over build automation over. Over 1 minute is enough. Then go with the Docker. So don't learn the Maven and don't learn the Nexus, don't learn the SonarQube. That is a developer's job. What we do, open the Jenkins, simply integrate all the tools, and that is also correct. That is also correct. Why should I unnecessarily make a comment on the people's mindset? Okay. So, but as part of the course curriculum, as a responsible faculty, I have to explain some build tools, right? Build and Maven and Gradle. Here in the build automation, you should know the build process. Build process in the sense step-by-step actions required to perform step-by-step step-by-step activities required to perform required to perform for generating the build process in the sense step by step. There is a build steps actually can say, right? Build step, that's called build life cycle. What is that? Build life cycle. That's why in entire development environment we have SDLC, STLC, bug life cycle, okay, and build life cycle, and DevOps life cycle, release life cycle. Okay, multiple cycles are there, right? Regression cycles, life cycle, regression life cycle. So STLs and and software testing life cycle and manual tester. That's why testing and okay, software development life cycle, software testing life cycle, bug life cycle, build life cycle. Bug is not only you, developers also involved, right? Huh? Huh? They should also find, right, whether it is a bug or not. Then if it is a bug, you developer is fixing. If they fix, I should involve it. How to take that code and how to modify, how to push it, right? It's a build and release process, right? So build cycle, build life cycle, it has its own step-by-step process is there, right? So there are 13 steps are there. Tomorrow we will explain the 13 steps, first half an hour. Then we'll introduce the Maven architecture, Maven principles, Maven elements, and how to configure Maven on the Linux operating system. Then what is a build file? Then onwards, we'll jump into the things, right? And before that, online, are you there?
Yes, sir.
Adinarayana, I want to ask you a kind of question to you as well as a Priyanka and other members also. So, is it possible to come down at 6 o'clock in the evening, 6 to 7:30? Priyanka,
Tomorrow
not tomorrow. Tomorrow onwards. Priyanka,
onwards. Yeah, fine with me, sir.
6 to 7:30, right? Thank
Uh,
you. Thank you
from
so
tomorrow
much.
to end of the course, till the
Yeah,
end of the course.
yeah. Thank you. Thank you so much. And Priyanka, Priyanka Karmakar, are you there? Okay, then. So we'll talk tomorrow. So tomorrow you just come at 7 o'clock. We will fix it. I think so. Narayana said okay. So Priyanka, I will ask them. Thank you. Recording.